Hi, welcome everyone. In this video, I will talk about the concept of compound continuously and the exponential growth. Now, let's go back to the first page, and on the way you are going to see many formulas here. First, the formula you can see is the compound n times in 1 year. I will explain what compound n times in 1 year means, and the compound 4 times in 1 year. So compound interest, what's that? And I will talk about it later. And the compound annually. Compound annually means you compound only 1 time in 1 year. Now, compare with the compound interest. There's another interest we call it simple interest. Simple interest means you use the initial principal all the time, no matter how many years you deposit your money, you put your money on the bank. But it depends on your initial deposit amount. They give you the interest. Now, so today I will show you when the formula n approach to infinity, then the formula will be different, but still based on the formula we are going to deduct. So compound continuously, another name is exponential growth. Same thing, I will explain more detailed concept later. But in order to understand exponential growth, this formula, very complicated formula, we are going to learn later. We need to understand the interest rate, compound interest first. But before we understand the compound interest, we want to talk about simple interest. Everything starts from simple, easy concept. So when you learn math, most teachers will say math is easy, and the students always complain. Why is easy? Because you are a teacher, you feel it's easy. I want to say we try to make math easy for the students. And if you learn the very easy, simple things, start from beginning and accumulate, you learn more and more complicated concept on top of the simple, easy concept. You may feel math not that complicated. So that's why we don't want to force you right now to adopt a very complicated formula without knowing what's going on, right? So it's better we start from the simple interest. Say you deposit your money on the bank. So if you deposit your money on the bank, the final amount, A. If you put on the first year, in the end of first year, we can calculate your amount. And you deposit initial amount, we use this symbol on this video. So say if you deposit $100 and the annual rate, say if it's 0.011%, for example, and you put your money on the bank for 1 year, then in the end of the first year, you are going to earn 100 times 0.01 and you put it in 1 year, which is $1. So your final amount will be $1. So this R means annual interest rate. So all over the video, when we talk about R, it means annual. This rate give you 0.01 or 1% is because you put your money on the bank for 1 year, and we calculate your interest rate in the end of the year. Now, if you want to calculate your interest rate many times in 1 year, then definitely we won't be able to give you this very good rate, because this rate is for 1 year. Okay? Now, T means you put it on the bank for 1 year, 2 years, 3 years. Okay, depends on how many years. And the N will be the number of the terms. Compound. We are going to talk about compound later. So when we are talking about simple interest, we don't talk about this, not yet. Okay? So if now we concentrate on the simple interest. Now, on the second year, I made some mistake. Total amount, if you put the interest, if you put your initial principal $100 on the bank for 1 year, you earn interest $1. But what's your final amount? You have 101. Yes? Yes. And the second year, you begin with $101. But when the bank calculate your interest, they still based on $100, because that's how we call simple interest. They calculate a very simple way. They use initial amount $100, no matter how much amount you already have in the bank. So use the same formula and the same rate. You put another 1 year, so you earn another $1 interest. So you plus 1 again, so you have 102. Okay? Let me make it looks like a formula, looks like a proof. So you have $100 plus 1 and plus 1, right? This same thing. Another 1 year, you have another $1. So you have 100 plus 1 and plus 1, that's 102. And you have another $1, you have 103. So pretty obvious. You plus 1 in the end of first year, plus 2 in the end of third year, plus in the end of second year, plus 3 in the end of the third year. So you can imagine, without calculate again, you have $100 plus 4 times interest. So you have 104. On the fifth year, you have 100 plus 5 times interest is $1 for every year. You have 105. So same thing, same rate. You always earn only $1 every year. So we don't know what's T. T means probably 99 years, probably 999 years. You don't know. We make a formula. It will be your original $100 plus you have $1 for every year, and you have T years. So it will be 100 plus T. And how this $1 came from is your original $100 times rate. And this $100 is your original principal. So plus all together, this is our formula. Is P0. We can pull out the common factor P0. And P0 means P0 times 1. So here 1 plus TR. 1 plus TR. Okay? So I will keep everything here so you can understand. You can review and see also. So I'm not going to erase all the example for $1 and the 0.01 rate, but the real formula will be here. Okay. So based on the same idea, but we change our interest to compound annually. Means if you have principal and then for the first year, your amount will be your principal plus your new interest. Agree? And we may pull out the common factor. This means 1. Okay, so you pull out the common factor P0, then you have 1 plus R. Okay, so that's first year. And the second year, because this compound annually means not a simple interest, not simple. What's the difference between simple interest and the compound interest? Simple interest always use the same principle all the time, but the compound interest, they use your new amount. So your new amount will be P0 times 1 plus R. So based on your new principle, this principle will become new principle P0 1 plus R. And then you times R for another year. Okay? Now how you do that? Your original, in the end of first year, your original amount, say your new principal is this amount. And then plus the interest, that's a new interest. New interest. Because 1 year, we don't need to multiply 1, right? So you have P0, 1 plus R, and times R. Okay, now pay attention here. I'm going to show you the calculating skill, algebra calculating skill. You can see there's a common factor, and the whole thing multiplied with 1. So when we pull out the common factor, we have P0, 1 plus R, and what's the leftover? Leftover is 1 plus R. So you have 1 plus R. Okay, and you may see that's P0, 1 plus R square. Very good, right? So you can see the second year, you have square. Make a formula easy to memorize. Okay, but I imagine you, I assume after you learn how to deduct the formula, probably it's very easy to memorize the formula because you are so familiar with the formula. Now, the new principle, the final amount will become your new principle. 2. And you can guess your new final amount is supposed to be 3. Let's try to prove it. Okay. So right now your third year interest will based on your new amount P0 1 plus R square and times R for 1 year, right? So this 1 is times 1, nothing. Okay. So we may calculate our total amount in the third year. Total amount will be square. So P0 1 plus R square and plus your new interest 1 plus R square times R. So same algebra calculating. We try to pull out the common factor. Common factor is P0 square, P0 1 plus R square. Okay, so we pull out common factor. And this means times 1, right? So we have 1 plus R. So we have 1 plus R. And do you see that? Square and 1. So 1 plus R cube. So we can see that first, in the end of first year, that's a formula. So in the end of T year, your final amount will be P0, 1 plus R to the T. Now, do you agree? So I will give you a little time to think about that. So you need to have very strong algebra calculating skill to understand the formula. Now you can spend more time after the class, after you watching the whole video. You can pay attention on the calculating. If you not quite understand, you can review this video again and again. By doing this, you may improve your calculating skill in algebra. Okay, now I would like you to pay attention on the new formula. That's very important formula. And we are going to base on this very important formula to develop a formula for not the compound annually. Compound annually means you compound one time in 1 year. Okay, how about if you compound more times? So we say compound 4 times in 1 year. 4 times in 1 year. What happened? If you compound 4 times in 1 year, then you need to times 4. Agree? 4 times. Because you every time you compound, you increase your exponent. But if you compound 4 times in 1 year, this R is annually rate. So I don't suppose to give you the full in annually rate. So in 1 year, I give you interest rate 0.01. And if you want to compound 4 times, every time I give 0.01 divided by 4. It's fair, right? Okay, so then you have the formula. You divide by the number of the time you want to compound in 1 year, and then you times 4. Okay, so the next chart is very similar to the calculating we have here. you can just copy the calculating here, but you change your rate to R divided by 4. So let's try this one. Okay. So your principal still P0. Let me change it to red color. You have P0. And the interest will be P0 times R in 1 year. So your total amount will be P0. Sorry, the rate need to be divided by 4 because we, okay. And the interest, you still use 1 because this 1 means 1 time, okay? So you have P0 plus P0 R divided by 4. Okay. And we can pull out the common factor P0 and 1 plus R over 4. And the second time, your new principal P0, 1 plus R divided by 4. And then you have P0 R divided by 4. Oh, sorry. P0 1 plus R divided by 4. And you have another 1 year. That's 1 quarter. You have 1 quarter. So this one, P0 1 plus R over 4, and the plus new interest P0 1 plus R over 4. Sorry, there's R here. Sorry, I need to multiply with that's interest. You need to multiply with the interest rate and then 1 time. Okay. So you have another R divided by 4. Because this multiply 1, you don't need to worry about that. Okay. Now pull out the common factor. You have common factor P0 1 plus R over 4. And what's the leftover? So this times 1 here. So you have 1 plus R over 4. So you have P0 1 plus R over 4. You have how many times? 2, because that's the second time. Okay. Now copy down the same thing. Third time you have P0 1 plus R over 4. Third. Okay. So in the end of first year, then you have P0 1 plus R over 4. You have 4. But remember, this is just 1 year. So there's 4 times 1 year because you have 4 times in 1 year. Make sense? Okay. So in the end of the second year, you're supposed to have P0 1 plus R over 4. Now you have 4 times and you have 2 years. So you have 8 times. Totally 8 times. Oh, sorry. I need to put down here. P0 1 plus R over 4. Okay. So you have 2 years times 4, because in 2 years you compound 8 times, 4 times, and 4 times. Every time you, so this is 4 times, right? First year you have 4 times, second year you have 4 times, and in the end of the third year, you have the total amount will be P0, 1 plus, every time you compound, your interest rate need to divide by 4. And for the T years, every year you have 4 times. So that's how you have the final formula for compound quarterly. 4 times means quarterly. Now, when this compound quarterly become compound n times, there's the same idea. I don't need to deduct the formula again. So based on the compound annually, if I compound annually, the formula will be original formula. A is P0, 1 plus R, and depends on how many years. But because you want to compound so many times in 1 year, so if you compound n times in 1 year, every time I will give you the interest rate supposed to be divided by n. It makes sense, right? Now, so based on the deduct formula here, I think it's not too hard to understand so far. The thing is, I don't know if bank will give you the I don't know how the bank works, because I'm not a banker, or I don't manage my money very complicated. So simple interest I understand. Compound annually I understand. Compound quarterly maybe, but compound n times, I don't know how many times the bank will allow you to compound n times. If you compound n times, many times in 1 year, say if the bank compound your interest every day, compound daily, you will become very rich. I don't think they can provide the same interest rate, annually rate for you, but I don't discuss this one right now. Right now, the reason why we talk about compound annually is because we want to talk about exponential growth. Exponential growth is same as the interest rate compound. Like if you order a cup of milk, okay, a cup of milk, okay, so that's a milk. This milk, you bring this milk to under the sunshine. Let me change the color for the sunshine. Wow, sunshine, right? Wow, very hot, heat. You bring the milk outside and drink the milk, but every time you only drink a little bit, a sip of the milk, and then you left most of milk. Okay, you left most of milk under the sunshine for a very long time, and you forgot to drink it. What happened? The bacteria will grow. And I will say we assume the bacteria will grow like interest. And what's the rate? I don't know, because I'm not a biologist. But anyway, you understand the bacteria the milk will be spoiled, and the bacteria will grow and grow and grow. How it grow? There's a rate. Even though I don't know what's the rate, depends on sunshine, how hot it is, and what type of milk, or many conditions. But one thing is, the bacteria grow in the milk won't be compound annually. Won't. They will keep going on compound, right? Keep going on growth. You say, teacher, how about compound every minute? So did you mean the bacteria grow every minute and stop and wait until next minute, then keep going on growth one more time and stop and wait for 1 minute to grow the bacteria? No such things, right? In the nature, if you consider it, the bacteria is growth. The growth will be continuously. So we are talking about compound. Continuous. So compound continuously, it make more sense when the bacteria keep going on grow. So not every minute, not every second, it's every moment. So continuous grow every moment. So what's every moment? It means we talk about compound continuous. So what's n? How many times? N times in 1 year. So the n, what you mean n times? If the bacteria keep going, grow. So I will say many times. Many times. And many times. How many? We goes to infinity. Infinity times. Infinity means out of count. You cannot count, so we have a symbol, infinity symbol. So when this n is not a number, that's the problem. Let me erase. Okay. So when the n in the formula is not a number, is infinity. Can you calculate? No way you can calculate. Therefore, we need to have a new formula when we are talking about the condition of bacterial growth. Not only for bacterial growth, we talk about the chemical situation. So we are talking about the radiation. There are so many word problems. You may see that in when we talk about the exponential growth, and when you talk about when you deal with the word problem, you have to remember when they talk about exponential growth or exponential decay. So you put the money on the bank. We assume rate is positive, but actually, in the recent year, we may see the interest rate may be negative. Yeah, you already see the rate may be 0. So rate positive is normal, but we also see some bank the recent year they provide they ask for negative rate. Means you need to pay interest rate to bank because they keep your money safe. Okay, but when we talk about exponential growth or exponential decay. Anyway, we talk about when the rate is positive or when the rate is negative. But the formula are all the same. And keep in mind, this n, because we talk about exponential growth, exponential decay, basically is talking about the same idea of compound continuously. So next time when you see compound continuously, please understand we are talking about compound to how many times? Infinite many times. Okay, many times. Now the problem is, if I said that we cannot calculate with infinite symbol, and the n is infinite many numbers, infinite many. Now how we calculate? The new formula is this. Okay, but you need to learn calculus in order to understand the process. How can we convert? How can we convert this compound formula, compound continuously formula, to become an exponential formula? Exponential means you have exponent. Okay, we have exponent here, right? But exponential growth, basically your base is e. Okay, and your rate and the time also is talked about here. Is in the exponent. Okay, so the most important proof, sorry, I cannot provide to you because you need to understand the calculus. To understand how we can convert the compound continuous formula to become exponential growth or decay formula. Okay, but I think after you go over so much detail, you will understand what exponential growth means. You can use the example of the bacteria grow continuously. So you need to calculate the total amount by using the new formula. Okay. Now in this video, I'm not going to go over all the problem because I think the concept is more important, and you probably cannot find the concept explanation from otherwhere. So I focus on this part. But in the end of formula, in the end of this video, I want to talk about half time and the doubling time. So if I'm talking about the exponential growth, and what the half time means. So for example, if you have a chemical radiation and you have the stuff will be decay the amount. So half time means your original, when you have original amount and after the exponential decay, and it become half. of the original amount. And the half time is this time. Okay, they tell you what's the half time. You can have the original initial amount become half. So this is the half time. Okay. And the doubling time is very similar concept. You have same formula, but the rate is positive, so you are going to have more and more. And what time you are going to double your initial amount? This time we call doubling time. Now you may see there's a lot of formula tell you the to show you, but you don't need to memorize. I will suggest my students, you simply remember half time. You memorize the formula, right? You memorize this same formula. Very easy formula. I will say A equal to P E R T. That's easier way to memorize. And when this P become half, or when this A become half of the P, or this A become double P, the time is talking about half time or doubling time. Now let me show you the formula, but you don't need to memorize the formula. Okay, so let me change color. Okay, so how I deduct the formula? I divide by P0. So I have half equals to ERT. And how I solve T? I put the ln. I put the ln. So ln and the E is gone. Now what do I have? I have RT equals to ln half. And how I solve T? I divide by R, right? I divide by R. So you have the formula T equals to ln 1/2 divided by R. In most of the formula, when we talk about exponential growth, we don't use R, we use K. We use K. So most of the time they ask you to solve for K, you can solve for K. But if you want to use the formula, so this is K. Okay? And the formula will be T. And similarly, this T, the formula will be ln2 because this 1/2 for the doubling time is 2. And divided by R when we say K. The formula. And many students memorize the formula. K equals to ln2 over T, or T equals to ln2 over K, because you can exchange these two positions. Okay. I don't suggest that you memorize the formula. If you really like to memorize a lot of formula, you can do so. But for me, I don't want to memorize too many formulas. So I rather to just memorize this formula and understand what half time means. Half time means this one become half, and doubling time means this one become double. And then I do some algebra calculating, reducing. I divide by P0 on both sides and put the ln on both sides. I can easily solve for everything. Okay, so another concept I want to teach you is try to minimize the number of the formula you need to memorize. But if you insist you want to memorize, that's good for you. You can memorize, but make sure you memorize correctly. Okay, so thanks for watching, and wait for my next video. See you next time. Bye bye.